Okay, I think we will wait for about 2 minutes to start. Yeah, people are coming. Okay. Hello, Super Chicken.
We can begin.
What I mean, I think, yeah. So you start first, right?
All right. I'm going to begin. Um, Welcome, everyone. I'm really excited to show you a deep dive into into Honeycomb Protocol. We've been building this framework for the past 2 years, and I'm really excited to show you everything we've built and everything we're going to build. I am joined by our CTO, Ghulam. His nickname is GM Rosa. I will be covering the introduction, and he will be covering the technical parts. But at any point, if you have any questions, you can just ask in the chat, and we will do our best to answer. So let's begin. So why did we start building Honeycomb Protocol? So we noticed that building anything on Web3, let alone games, is very, very complex. Was very, very complex, rather, because you have to deal with smart contracts, you have to pass accounts correctly. That's not even factoring in the on-chain costs. If you create a PDA, that's very, very expensive. Uh, Considering that in order for a fairly complex game to function, you would have each player would have to own multiple PDAs, and that gets very costly both for the players and the developers, right? So we set out to simplify that. Um, First of all, we wanted to create tools for game developers to greatly simplify their development. So now game developers can integrate Web3 into their game with just a few lines of code, whereas previously they would have to spend weeks, even months integrating Web3. Now it's just a matter of days, right? And for users, we realize that a lot of users are skeptical about crypto, and they would rather not use it. So we've enabled developers to sort of hide the Web3 elements. The users won't even, if you don't want the users to know they're using Web3, they won't even know, but they will own all of the characters and the items, in-game items like swords or armor. They will own them, but they won't necessarily be paying the on-chain costs and signing transactions. You can do all of that in the background, as Ulam will show later down in the demo. So let's see what kind of cost reductions we've achieved, right? By using Solana's on-chain primitives and generalized state compression, we've reduced fees for on-chain accounts by as much as 1,000 times, but we've seen an average of around 350, right? Compared to creating a PDA, storing data in our Merkle trees has been greatly beneficial, and whereas the costs were prohibitive even for developers before, they're very much now in reach. for both players and developers. So it no longer needs to be a huge game studio with millions of dollars to create a Web3 game now. These are our current primitives that are currently live. I'll go through them one by one very briefly. First of all, we have Hive Control. Hive Control is the master program that sees all of the rest of our primitives. And it begins by projects. Every app you create on Honeycomb Protocol, that is going to be a project. Whether it's a game or an app, that's a separate project, right? And one of the most powerful features Honeycomb offers you is delegate authority, right? Delegate authority is basically, as the person who creates the project, you have complete authority of the project. Everything you see here, you can make changes to it, you can create, you can delete, but you might not want to micromanage every aspect of your project. So that's why you delegate parts of your project to a different key or a different user, an employee, maybe a programmable wallet, right? And that, due to that delegation, that wallet, whether it's a programmable wallet or an employee, they will only be able to do that particular thing. Let's say I let a user create missions. I only give them the permission to create missions, and they will only be able to do this and nothing. They won't be able to touch anything else. Another scenario, another really common scenario is resources, right? You might want to, according to a leaderboard in your game, you might want to distribute on-chain tokens to your users. The person who comes on first in the leaderboard, they get a lot of tokens and whatnot. So you might want a programmable wallet for that, and you store a key on your server, and you delegate delegate resource manager only the ability to mint tokens on resource manager to that key, and it will only be able to do that. And it's no longer a security risk because it won't be able to touch character manager, staking, or any of the other stuff. In addition to that, Hive Control also manages player profiles, and our player profiles can store any custom data you choose, including their XP and levels, and you might want to store their country, and anything you can imagine it can store. But the advantage is that the player profile is on chain, and all of the data associated will be on chain as well. The next thing is HBR EdgeKit, also called the Edge Client. And the Edge client greatly simplifies transaction creation and transaction signing. So usually when you interact with on-chain programs on Solana, you have to pass in dozens of programs, and especially if you're dealing with compressed data, you have to pass in associated accounts that need to be completely correct. If you mess up even one part of it, the whole transaction fails. So our Edge client takes care of that. It's a GraphQL server. It takes care of all of that, and you only need to pass in 4 to 5 accounts, relevant ones, and all of the compressed data and passing in the proofs and all of that stuff is taken care of. The next we have quests and staking. So since you can create characters on Honeycomb Protocol, you can send them on quests, both custom and time-based. So custom quests would be like raiding a dungeon or defeating a boss, right? Your game will tell us that, hey, this quest has been completed, and you would reward them using Resource Manager. So that would be a custom quest. The timed quest would be that no matter what happens, uh, the NFT gets locked, the character gets locked for a week, and at the end of that week, they receive some reward. It doesn't have to be a week, it can be a day or an hour. And then we have staking. We can let you stake characters, which are basically NFTs and tokens, and receive rewards, APR-based rewards. And next we have Character Manager. Character Manager has a lot of users in games that have NFTs and that you want to use as characters, and you can do everything with our character manager that you can do in a Web2 game and characters, right? If you want them to be able to equip swords, you can issue swords using Resource Manager in response to an in-game event. We also have crafting, so you can combine multiple resources and create a sword, like let's say an iron bar and coal. Um, so you can define the recipe, and if your players have the necessary equipment, necessary resources, they can come and combine them. You can also use resources as in-game coins. Let's say I have gems, and I only want to be able to use gems in order to equip a sword, and that's very much possible. Um, you can also use health potions, like you can issue health potions using Resource Manager, and that can heal your character. Uh, you can equip armor and swords, and that can upgrade your character. And the character manager NFTs are dynamic. So let's say your character evolves. Initially it was a very basic character, right? And over the course of the game, they become a really experienced soldier, right? So as you update the metadata, right, the NFT, the character will visually change, even on the chain, right? The on-chain data that the visual upgrades don't get reflected as quickly on marketplaces because they have cached their data, but they will get reflected um, in a few days. Or with Tensor, you can request the refresh of metadata. So that's very much possible. Um, let's see what we are currently working on and what's coming to Honeycomb Protocol in the future. So we have Shadow Signer. We were working on our own implementation of this feature. So but we've paused it. So the logic behind it is that um, every time a player wants to do something on chain, they have to sign a transaction, right? And that interrupts the gameplay. Let's say a player is using a particular resource to attack a boss. Every time they attack a boss, let's say you've issued arrows using Resource Manager and they use an arrow. Every time they would have to sign a transaction. And that interrupts gameplay. That makes the gameplay a lot less exciting. So we're working on Shadow Signer or something similar to it so that players don't have to sign transactions and it's still secure so that nobody else can spend that resource. If the player owns that resource, nobody else can spend it, but they don't have to sign transactions constantly just to be able to play the game. Next, payment manager is coming soon. So if you want your players to be able to purchase a character or a resource, let's say you have gold and as a resource and you want them to be able to spend gold to upgrade a character, right? Payment manager will handle all of that, all of the in-game purchases. Payment manager will handle all of that. The next thing is we have guild kit, and guilds let players bunch together and create a guild with a hierarchy. There will be a guild leader, and he will have lieutenants and common members, and the whole guild will be able to take part in a mission, in a custom mission or in timed missions, and whatever that mission rewards, you guys will be able to get rewards equally. And the guild leader can decide if the rewards are distributed equally or it's hierarchy based that the leader gets more rewards than others. The guild leader can decide that easily. And next we have Agent Kit, and that's a very exciting feature that will be coming. We will be combining AI with Honeycomb Protocol to make the experience better for both developers and players. So it will be an AI agent. Developers will be able to come to Agent Kit and say that I want to create a game like Angry Birds with a token called $angry. And the game will create all of the resources for you, as many as possible, and all you need to do is customize the resources. Maybe you want a different logo for the game. Maybe you want the birds to look a little bit different. You replace the graphics and customize the programming, but it will be done. And for the players, let's say I'm a player and I want some of my stuff to be automated. I want 5 characters to be sent on a mission, on a timed mission. I come to Agent Kit and I say, hey, I want these 5 characters to be sent on the mission, and it will automate it for you. And let's say you're playing a strategy game, an RPG, where there's a, a lot of strategy needed to defeat a boss, and you don't know the correct strategy. So you come to Agent Kit and you ask Agent Kit, hey, what strategy do I need? What type of items do I need to craft in Resource Manager to defeat this boss? And it will tell you, and maybe even craft them for you. It depends on what the developers enable, right? We will obviously try to protect games like chess from Agent Kit, like it won't give players the answers, but developers can enable or disable that. And at this point, Ghulam, our CTO, will be taking over this presentation. Over to you, Ghulam.
Right. Thank you, Shoaib. Hello, everyone. So I'm here to just discuss deep dive of tech when it comes to Honeycomb Protocol, and the whole idea of Honeycomb Protocol is to be uh, a Web3 solution, but as agnostic as possible when it comes to base layer. So we are not depending on, we are still dependent on the SVM runtime, but we are not depending on just on Solana, for example. Mean that we are also exploring other options when it comes to base gen. At the same time, we are accumulating interactions. So, for example, regardless whatever the client side you have, be it Godot, Unity, TypeScript, all the other client side we are working on, and you can basically integrate our Honeycomb protocol and all the APIs using your native client and all the type systems, so that you don't have to worry about the API responses and things like that. Although under the hood we are still using the GraphQL API, but you don't have to worry about that. You'll get a typed client in your preferred language or SDK, and then you can just use it as you use any other SDK for game development. And on the flip side, we are also integrating with marketplaces like Tensor, for example, and for smart wallets, we are also integrating other wallets and whatnot. And the whole idea is that we provide a very agnostic solution where we are providing primitives, but however you guys want to integrate as a developer, it's up to you. Like you want to use Solana L1 with maybe Unreal or Godot front end, or maybe you want to use Tensor Marketplace, which is obviously on Solana L1, so you can use it there, and you want to use maybe MetaKeep wallet for user identification. So we have all the options. You just configure it and then you can use it. And we don't limit you to use any particular solution for any need, other than Honeycomb, of course, for on-chain primitives. Uh, yeah, next slide, please. Sure. All right. Uh, so basically, the way we does it is, as Shoaib has before mentioned, that we have solved the cost problem by solving, by basically compressing the state on L1, and that's what we are doing. It basically reduces on-chain storage cost, and it's great. Like since we have all the data on-chain, but it's still cost effective for game developers and users, obviously, eventually. So that's one way to scale it, and we believe that's like we still have a way to go. Like we can scale it further, but after that there is a limitation which we are anticipating, which is on the bandwidth side. So considering we are agnostic, and then we also think like there might be some bandwidth issues, because imagine all of the block space is going with DeFi, because they are the highest bidder. So we are in the problem then. So that's exactly why. So this is the current approach, like L1, and we are trying to scale it. But as you guys can see, the architecture for this, we can come to L2 approaches in later slides. So here, as you guys can see, like we have a wallet, and essentially user shows intent, create a transaction using our edge client SDK. That's all happening under the hood. So basically, you request a certain thing, and then we create the transaction using the data of all the compressed data and all the transaction, right transaction, and we choose that and create the transaction and send you transaction back as a serialized transaction on the front end side. And essentially you ask user to sign it using the supported wallets, which are essentially all the Solana wallets, MetaKeep and whatnot. We also have like reference implementations for them. But yeah, essentially you sign the transaction and then you send it back to Edge client, and then Edge client handles it all the backend, like send it to RPC, send it RPC essentially like execute the programs, which will eventually settle data in Ledger. Uh, and then we basically ingest those all events or changelog and basically start indexing those data, which eventually be available for the edge client to do the next steps, like all keep data updated so that we have a valid transitions and whatnot. And that's how we are scaling the L1 using the compression. Do you have any questions? Does anyone have any question in this? Yeah, what is the difference between your solution with the ZK compression? So, yeah, essentially, we were predated to ZK compression. Uh, they are good, in my opinion, but our solution is mostly based on the Merkle tree. So we have Merkleization on chain and changelog on chain. That's like similarities with us and ZK compression. But the way we differ with them is the proof. So they have the uh, ZK proof mechanism. The way they validate the data integrity is ZK proofs. On the other hand, we use Merkle proofs. So that's the difference per se. But logistics wise and indexing wise, things are pretty much similar. Does anyone has any other question? I hope this has answered my question. Or yeah, let's move to the next slide. Beyond L1. So yeah, essentially, uh, so you have Solana L1 settled, as we have discussed that we might have a bandwidth problem because of the block space and whatnot. So we are also exploring the other SVM, which is Sonic, which named Sonic, Soon, Termina, and Eclipse. So essentially, we are exploring with them and trying to deploy our infrastructure on each chain one by one, so that we have more options for our game developers to choose from. And this implementation looks exactly like what we have shown before in the last diagram. And it's just the base layer is different. So all, all the infrastructure needs to be redeployed for that specific blockchain. Next slide, please. All right. Uh, Other than this L2 approaches, there is one more approach, which is roll up approach, for which we are a bit of context. So uh, either you do L2 or you do roll up. So in the Solana, essentially you have Hypergrade roll up by Sonic team and then Magic Block roll up. Uh, both have some different characteristics, but essentially, what all of them both of them does is they have an execution layer, which is isolated from the settlement or base layer, and base layer can be anything like Solana L1 or maybe Sonic Element or whatnot, Sonic mainnet. But essentially, they have this runtime, and then you have to settle data on certain mainnet. The problem with compression is that you have the change logs, and you can either make the integrity of change logs on your settlement layer or keep the integrity on your execution layer. Both are not possible, because if you rely on both informations, then essentially you will have a corrupted data. uh, and that's the problem, and that's something we are currently trying to solve with the Magic Block team and the Sonic Hypergrade team. Since both of their solutions are different, uh, we are working on different solutions with both of them. So essentially, we'll have a compression ready integration with rollups soon, hopefully. Right. This next slide is all about smart wallets or shadow signers per se. Uh, so essentially, the idea is to allow game players to interact with the game without worrying about it. So there are many kind of users, right? You can categorize users with Web3 native users like us, most of all the regions. Uh, then you can get the users who are just here to play the games, and then there are grifters. Either way, if you have a certain user base, you need to tackle their demand. So the biggest problem with the Web3 identity is Web3 identity, right? So you have wallet, you have to save the 24 phrase seed phrase and whatnot, and that's very problematic for non users per se, or non-crypto users who are interacting with the game. So the idea is like we have some sort of a smart wallet where it's recoverable. At the same time, it's fast. Like you don't have to sign the transaction and whatnot. So there are a couple of solutions we are working towards. One of them is we are working with the Squads team to have their programmable wallets in a compressed manner. So they are basically using ZK compression for that. And the idea is that once they'll have this compressed, yeah, so essentially when you have when you talk about a smart wallet or wallet abstraction, you have two kind of wallet abstractions. One is on chain, something like Squad's smart wallet, where you have all the programmability configured on chain and governed on chain, and then you have off chain wallets like MPC wallets, for example, MetaKeep and whatnot. So we are trying to build mix of both of them, kind of. Uh, One way we are trying to achieve on-chain registry in a compressed manner with the squads, so that we have all the programmability on-chain, like the core access control. But at the same time, in order to, for example, recover the account, we can use MetaKeep as a recovery option. So trying to build something a hybrid of both of these, which will be recoverable, which will be fast to execute, so that you just have the request and we just settles it without us bother you to sign the transaction, and which is secure. So these are the three criteria we are building this smart wallet or shadow signer. Any questions, you guys?
I have a question. Uh, okay, can you hear me?
Yes.
I just wonder if now I want to use the honeycomb, I have to use the honeycomb node, right? Well, I cannot use all the RPC network. Is it correct?
Partially correct, yes. Because so the thing is, like, you can view all the honeycomb assets, since we are using supported asset methods like CNFT per se in the code, or tokens per se on the code. So you can read, obviously, you can read the data like assets, but you can't read the data like PDA. Same as you can't read the PDA data for XYZ programs, right? So that's something we are working on on some sort of fork of Solana Explorer, and it will have that data. But essentially, yeah, you can't read the PDA, as you can't read the PDA of other programs, but you can read the assets, as we are using the supported uh, asset class.
Yeah,
Does it make sense?
yeah. And for now, currently we cannot use honeycomb with Sonic or Magic Block, right? We cannot compile right now.
Sorry, can you repeat the question?
I mean, for now, so I cannot use your honeycomb with your Sonic, right? I cannot use you because I want to deploy a game to Sonic, and I also
Mm.
want to compress the data with honeycomb. But for now, we cannot do together, right?
Yeah, true that. So we are live on Solana mainnet. We are live on Solana, Honeynet, which is basically a single node. Couple two node validator on the using SVM. But we are currently not, although we are live on Sonic testnet, but we are not publicly live. So we are just testing few things there, and it will be announced soon. So just shoot us in the DMs. We'll get you the alpha access. But yeah, that's the next thing we are deploying.
Yeah, yeah. Okay. I think we have a question in the chat. Can you read it?
So Cho is asking, consider using a programmable wallet for a easy login, and with gaming, you can completely avoid signing multiple times. Essentially, yes. So The way it works, I mean, we are still working on details, but the way it works is that you have multiple signers of a specific account, and based on certain rules, you can sign certain transactions. So the idea is that you have a access token, a Web2 access token. The moment you sign in, you sign basically using your primary controller wallet and give us the permission to do certain things based on your account. And then using that permission, our off-chain signer, which is another signing authority in your smart wallet, will sign the transaction. So it's like a toolkit to do so. And we can release this as an open source tool so that other platforms can essentially use that as well. Hope Joy it answers your question.
Yeah. Okay. Mm. Do you have any game with you, Honeycomb, to show us? And any game, any demonstration? I mean,
Yeah. I will let Shoaib take this one as a dev rep. Please, Shoaib.
So we've developed a couple of games internally. One is Soul Patrol, the other one is Ocean Explorers, and I think Ocean Explorers is live. I'll have to get back to you on that. But we plan on making them both open source and live, so you can not only see the games and use them, play them, but also use their source code as a guide on how to make a game on Honeycomb. But also, we're working with several integration partners, and a lot of them have very exciting projects. Um, some have RPGs that are very interesting, and they have an interesting storyline, and they use mechanics like World of Warcraft, where you go on dungeon raids and whatnot. But they will be coming soon. Stay tuned, and we will be posting updates to our Twitter and Discord.
yeah. Okay. Okay. If you guys have any question, feel free to chat, to comment on the chat. Mm. Okay, okay, okay. Yeah, I think no more question. If you have questions, feel free to join your Telegram channel and add your Honeycomb on your Telegram. Okay, thank you, Zaha and Sophie. I think thank you for your time. Yeah,
Thank you guys. We're really excited for you guys to use Honeycomb Protocol and all of the games that you guys make. Thank you for giving us the opportunity to go into this technical deep dive with you.
yeah, yeah.
Very
Okay, okay.
pleasure meeting you guys. Have a good
Yeah,
day.
thank you, and thank you everyone. Have a good night. See you next week.
Um, so Chao is saying that he didn't hear the answer very well. Uh,
Yeah.
All right.
Can you can you answer again or write on
Yeah,
the chat?
sure. So, Chow, the idea is like uh, we have a programmable wallet on chain. We can have multiple signers for that. And the way we are designing it is that you use your primary wallet, which is MetaKeep or any other MPC wallet as a normie or Phantom as a uh, crypto user, and you basically create this programmable wallet on chain as a proxy, and this proxy can be signed by either your account or can be by Guardian account, and that Guardian account is deployed by either game devs or by Honeycomb. You can choose one as a signing authority, and basically, in order to prove your identity, you will have to also send a message while you are starting the game session, saying that I'm allowing my this XYZ guardian, which is a trusted guardian, to sign on my behalf for next 2 hours or so. And essentially, uh, this guardian now will be validating this message and signing on behalf of you using your token. And that way we don't have to bother user to sign the transaction, because essentially this smart wallet is abstraction of actual wallet. That's how we are planning to make it work. And for sure, we can share you the slides, but these slides don't have the spec for smart wallet or programmable wallets. We are working on the spec wallet, so yeah, just let's connect on Telegram, and we can share specs with you, so that you can also comment on them.
Yeah, okay. Yes, I will be share on your Telegram, and yeah.
Sounds good.
Okay. So yeah, yeah. Okay. So once again, thank you, and thank you from Honeycomb Protocol team, and also thank people who joined us today. See you next week. Bye bye.
Bye.